Hello all. Today we are solving LeetCode problem number 865, smallest subtree with all the deepest nodes. So we are given a binary tree basically, and the output expected is we have to return the subtree which has the deepest node with it. So what is meant by deepest node? So according to the question, a node is called the deepest if it has the largest depth possible among any node in the entire tree. So let us understand this with the example 1. So if you see here, clearly these two nodes hold the highest depth. So which is 1, 2, 3, 4. So it holds 4, the depth is 4, and which is the level basically, and this is 3. So these all four nodes hold the level 3, and this 2, and this is 1. Right. So we have to return that binary tree or the subtree which has all the deepest nodes available in the tree. So basically we have two deepest node, one is 4 and 7. So we have to return the subtree which has both these nodes, which is this is the subtree. So this is what we are returning in the answer, right? So now what if we have one more node here, right? Or before going into that, what if we do not have this particular node? What happens? So we have only one node, which is the deepest node. So in that case we have to return only 7. So the output will be 7 if only one deepest node exists. If two deepest node exists, that is 7 and 4, this becomes 2, 7, 4, right? And what if we have two more nodes here, right? 9 and 11. So what happens? So we have two nodes here basically. So all these four nodes are the deepest nodes. Let me erase this for clear pitch view. So all these four nodes are the deepest node, and the subtree becomes the whole tree becomes a subtree, because this particular the whole tree holds all the four nodes. So there is no common root node to hold all these four nodes, right? So in that case we will be returning the complete tree, which is 3, 5, 1, 6, 2, 0, 8, null, null, 7, 4, right? So how do we solve this? We can use depth first search, DFS approach, and we should use a post order. Why post order? Because we have to find the depth, right? So this depth, for the finding this depth and choosing the subtree, we have to be very careful, and we have to have the left node or left child processed, followed by right child processed, and then the node being processed. So these two are majorly required for finding out the tree as well as calculating the depth. So because of that we have to follow this post order. So how does this flow goes? So let me erase this up. Yeah, better. So when we call the DFS function, so it starts from this particular node, which is the leftmost node, right? And then we process this node, and then we go to this node, and then we come to this rightmost node and we process 2, and then we process 5, and then we move here 0, we process 0 followed by 8 and 1, and finally we process the root node, right? So 1 2 3 4 5 6, oops, 5 6 7 8 and 9. So this is how we process this tree basically. So here we have to observe the pattern basically. Yeah, so in this 6, if you see, we have when we from the viewpoint of 6, we have no other node present here, so this will be none and none, and this will be the base case. So in the base case, if there is no node, right, we have to return 0 and none, right? And because of that, this particular level, we start, since we are starting from this leftmost node, this level becomes 0 plus 1 1, and the node becomes 6 here, right? And then we are jumping to 7, node 7, and we are processing here. So similarly, we will have none here and none here, and this will be 0, and this level will be 1, and this will be 7, similar, but the same way of processing which we are doing on 6. So here it will be 1 4, and now you have to have observation here. So we have the level, both the level is same here, which is 1 and 1, and because of that, this node becomes we have to take one any one of the level length here, and sum it with 1, and this becomes 2. And since these two elements are there, which means the two child exist, the node get updated, and this becomes 2 here, right? And then we are coming here and we have to check the length. So here the length is 1 and here the length is 2. So among these two, the length 2 is greater. We can come to a conclusion that this 2 is the depth, and the depth is greater, right? So we have to choose this particular node only because of that. And here the level becomes 3, 2 plus 1 3, and we are still holding the node 2. So repeating the same pattern here, this becomes 1 0 and 1 8, and this becomes 2 1. So among these two, this is 3 and this is 2. 3 is the highest depth, and because of that we hold here it becomes 4, and the node value becomes 2, right? So based on this, what are all the observation we can we can put in together? So from this we can say that we are choosing the left node when the length of the or depth of left is higher, right? So depth left is greater than depth right, we choose left node, right? And similarly, when depth right is greater than depth left, we choose right node, right? So here you can see that the depth of 2 is, depth of right is greater than depth of left, and hence we are choosing 2, right? And similarly here we have the depth of left, which is 3, is greater than depth of right, which is 2, so hence because of that we are choosing the left node, right? And when both of this case is not true, which is left and right are equal, In that case we are choosing that particular node. So clearly we can see that 1 and 1, these two nodes, the length is same left and right, and because of that we are choosing the same that particular node, not the left and right, choosing that node, right? So else we choose node. So we have the base case here and we have the rest of the logic here. So using this we can go ahead and code this up. So we are following DFS, right? So we have to define the function. So base case if it is not node, which is if it is null, return 0, none, right? And straight away we have to find the recursive call. We have to go with the recursive logic. So left depth and left node. Node dot left and right depth, right node. Right. And now we have to come up with a condition for choosing the node, right? So if left depth is greater than right depth, you have to the node becomes it anyway, it will be incremented, right? And the node we choose will be the highest one, right? So 1 plus length left depth left node, right? And elif right return 1 plus node, and else case return 1 plus, we can choose anything, it can be left or it can be right, but the left node will be processed first, so because of that I'm going with left node, I mean left depth, and this will be node, right? And that is it. We have to return the tree basically, so which means we have to return the node, right? So this should be DFS of root. We have to pass in root because root is defined here in the function, so because of that we have to pass in root to process it, and we need only the node, right, not the length, so because of that 1. So let us go ahead and run it. Yeah, and time complexity for this will be big O of n, and space complexity will be big O of n2, because we are processing each and every nodes, and because of that we have time complexity and space complexity as big O of n. And let us go ahead and submit it. And yes, so this is an efficient solution. Thank you.